Good morning. Let me discuss about semiconductor devices subject. Subject. In that, Unit 1, Semiconductor Diode. First one. Uh, First one, topics to be covered: introduction, classification of semiconductor, mass action law, then diffusion and depth current, PN junction diode. Then PN junction diode, power and reverse characteristics. Then energy structure of open circuit of PN junction diode. Then diode current equation for the PN junction. Then transition and diffusion capacitance, switching characteristics, and breakdown in PN junction diode. First topic, introduction. What is mean by semiconductor? Semiconductor is a substance which has resistivity in between conductors and insulators. What is mean by conductor? Conductor is nothing but it passes the electricity to flow through it. That is known as conductor. If we take an example, iron. Okay, insulator. What is mean by insulator? Insulator is nothing but it does not allows the electricity to pass through it. Example we can take. Okay, so semiconductor have the negative temperature coefficient of resistance. So why we are saying this one is a negative temperature coefficient resistance, because it decreases the resistance value with increase in temperature. So we are called as it is a negative temperature coefficient of resistance. We can take the example germanium and silicon for the semiconductor diode. So classification of semiconductor. It is classified into two types. One is the intrinsic semiconductor, another one is the eccentric semiconductor. What is intrinsic semiconductor? An intrinsic semiconductor is one which is made up of semiconductor material in its purely form. That is, originally we can take it at no other impurities will be added to it. That is known as intrinsic semiconductor. That is pure silicon or germanium. It can produce very narrow energy. So this is an example for intrinsic semiconductor. Next one, eccentric semiconductor. When a suitable metallic impurity is added to the intrinsic, that is pure semiconductor, it is called eccentric semiconductor. We can take, and that is originally we want to add impurity to the pure form. Example, gold. Okay, then by adding that impurity, that is known as doping. That is, the process of adding impurity to a pure semiconductor is called doping. So depending upon the doping, depending upon it, it can be transferred into two types. One is the N type, another one is the P type. N type means, if for example we are taking the pentavalent impurity, that means it has the 5 valence electrons, means it in that 4 valence electrons will be occupied, one will be left free. That electrons will known as the free electrons. So that's why they are saying when a small amount of pentavalent impurity, that is added to the semiconductor, then a large amount of free electrons are free out. This is called as N-type semiconductor. This here we are taking N-type crystalline structure, that is germanium we are taking. It has a 5 valent impurity. So in this 4 will be occupied here. 4 will be occupied and remaining 1 will be left free. This indicates the N-type crystalline structures. Next one, P-type semiconductor. When a small amount of trivalent impurity, that is 3 valence electrons, is added to the semiconductor, so that exit a large number of holes in the semiconductor crystals. So it can create a hole, that is known as P-type semiconductor. P-type semiconductor crystal, when we are taking the trivalent impurity, that is the 5 valence electrons or 4 valence electrons, in this 3 will be occupied here, 1 will be left free. That is, that can create a holes, that is known as P-type crystalline structures. Let me see about the difference between the intrinsic and eccentric semiconductor. Intrinsic semiconductor, so it is the pure form of the semiconductor. So but eccentric, we want to add the impurities to the pure one. Example, we are taking pure silicon and germanium. In this silicon and germanium, we can taking gold, bismuth, etc. So in this, number of free electrons in the conduction band and number of holes in the valence band is exactly equal, but here it is unequal. Then electrical conductivity is low, here electrical conductivity is high. So it depends only on the temperature intensity, but it depends on both the temperature and the impurity added to it. That is the main difference between intrinsic and extrinsic. Okay. Next, comparison between N-type and